We're solving problem 11 from the 2024 F equals MA exam. Two hemispherical shells can be pressed together to form an airtight sphere of radius 40 centimeters. Suppose the shells are pressed together at a high altitude, where the air pressure is half its value at sea level. The sphere is then returned to sea level, where the air pressure is 10 to the power 5 PA. What force F, applied directly outward to each hemisphere, is required to pull them apart? So, well, we have this rather just sphere. It's supposed to be a hemispherical sphere. And they're pressed together at high altitude where the air pressure is half its value at sea level. So, well, we can just say that, well, there's a pressure pushing on this. A force like pressing on the hemispheres. And there's going to be a force F pushing back. Now, we can denote this, that this is going to be our pressure P. So we have this, and we know that it covers the whole of the sphere, and our pressure force F is pushing back. Now when you bring it back to sea level, all of a sudden, well, this force, they have to balance to be pulled apart. So this is P over 2. And this, there has to be an also outward force of P over 2. So we want a force applied directly to each hemisphere. So it's applied in all directions to each hemisphere to yank it apart. And we know that, well, F equals our force, pressure, P over 2, times our area. And since the area of the circle is pi r squared, we can just write that, pi r squared. Now we can substitute in values. Well, we know that the air pressure at sea level is 10 to the power 5 PA divided by 2. And then pi, let's make that 3.14. Radius is 40 centimeters, but since we want it in newtons, you would square it. And well, since newtons is meters per second, we have centimeters. That would be 0.4 centimeters squared. Yes. So, solving for all this using pi equals 3.14, the closest answer choice on our answer choices is A 25,000. 25,000 newtons of force in order to pull it apart.